Okay, so my talk is entitled Onion Architecture Without the Tiers. And so what I'm going to do is I'm going to just introduce Onion Architecture and why we bother talking about it. And then really the core of this talk is after an examination of the pattern, looking at various ways of actually implementing that pattern with Entity Framework. So it really is, how do we take these ideas and make them actually work in code, which can present quite a bit of a challenge. And I'm going to present how we went about fixing it and the library we made to do that. Obviously, it's not the only Onion architecture solution out there, and obviously different teams will have very different opinions on how to go about building it, but we'll show you what's been working for us and point out some of the pitfalls and some of the ways around it and alternative ways you could go forward. So the main reason we really care about architecture and why we sort of spend time scratching our heads and agonising over what we should do and why we shouldn't is what we want to avoid is spaghetti code. And I've got a great quote here that I found on the web. No idea who this guy is, but it's the best definition I've seen so far. And it's, in spaghetti code, the relations between the pieces of code are so tangled that it's nearly impossible to add or change something without unpredictably breaking something somewhere else. Now, I know I have, and I'm pretty sure most people have, started a brand new project with the best of intentions. I'm going to make this one the best one yet. I'm going to keep it clean, I'm going to keep it nice, I'm going to do all the right things. And somewhere along the line, a few months in, things just start to get difficult. Some decision you made 6 months ago, when it was nice and clean, just suddenly stopped you from being able to do stuff. And then suddenly, you're stuck, and you've got bits of code that can't be changed anywhere else. And so, accidentally, you've got spaghetti code. And so the next slide is how to make spaghetti code. And it's actually really easy to make spaghetti code. And it's all about dependencies. So you make a thing. That thing works quite well, it's nice and clean. You make another thing. That works well too, brilliant. Then thing A and thing B need to work together. All right, so I'll plug them together. Thing A and thing B are talking to each other, they're doing their job. Then you make the mistake, and you suddenly make thing B also need thing A. The minute you do that, the two things are locked together in an embrace until death. And that's when you get spaghetti code. So really, you have to start thinking about your dependencies and keeping your dependencies between the components of your system in a one-way chain. This thing depends on this thing, but this thing doesn't depend on the next thing up. So Onion architecture is quite a recent term, really, and it really is a snappy name for user interfaces. I think quite a few people were building code in this kind of pattern. But the term Onion architecture really took off because it did really neatly explain what a few people were doing anyway. So the key thing about Onion architecture, the core concept, is that right in the middle you have your domain entities. So what your domain entities are is they are simple objects that describe your problem. That they describe the things in your system, such as your customer, your order, your product. And the goal with Onion architecture is to build your domain entities with as few or no dependencies. So make your domain entities as complex as you can, as much logic as you can, without adding a single dependency. Because that models the stuff you can do. Then, everything on top of that builds up in a one-way chain, and everything in that chain going out from the onion is an interface. So you only ever get two pieces of code that talk together by using an interface. Then on the side, you have all your actual dependencies, the actual concrete implementations of those interfaces. So in this example, the repository interfaces, they depend on the domain entities. The business logic interfaces, they depend on the repository interfaces, and the clients, they look inwards too. But it means you can't make a mistake of you prevent it from having the mistake of making your business logic depend on your repositories, and your processes also depend on your business logic. So it makes a marked difference between your classic N-tier app. With your N-tier app, you really are talking about your database first. Your database is where you put your system, where you put your architecture, where you put your logic. And then you've got a logic tier and presentation tier on top. In Onion architecture, you don't really worry about your database as a central concept for your system. And I'll talk a bit more about the difference between domain-centric and database-centric a little bit later. So the key concept of onion architecture is it's an architectural pattern where the core object model is represented in a way that does not accept dependencies unless stable code. As I've already said, it's domain-centric, not database-centric. All the application components communicate via interfaces. The individual components that you make can be independently tested. You use dependency injection to wire it all together. And one of the main reasons for having this system is then, as over time, you start to know where your code should go, which is a very important concept. Because if you spend your time thinking, oh, should I put it in here or should I put it in there? You try it out in here and everything breaks, so you try it out there and then you've suddenly got spaghetti code. Knowing in advance where to put things because of the type of thing it is can save you a lot of time. And one of the most important things is give yourself some rules and stick to them. It's far too easy when crunch time comes to have a beautiful system you've built up and then suddenly you've got some requirements, so you quickly throw together, get it working as quick as you can. If you don't come back and unpick that mess, it'll start turning into spaghetti code. So here's a little bit of a slide talking about the real difference between domain first versus data first. Now I'm choosing my words very carefully here. I'm using the words domain-centric because we are talking about an architecture where the domain is in the middle. Your objects are what's the core of the application, but this talk is not about domain-driven design. Domain-driven design is very often pushed together with onion architecture, and that takes these concepts even further than what I'm going to cover today. And I'll touch about some of that on the end. So I'll start with actually data domain first. So with domain, it's a different way of looking at your system. In domain world, the core of my system is the domain model. Things exist or live for me once they're loaded in memory and are available as objects that I can manipulate in C#. And with this kind of way of thinking, the database is just a persistent store. I don't care if it's a database. I don't care if it's going out to an XML file. I don't really care as long as when I send it somewhere, I get it back the same. The database-driven model is quite different because in the data model, it's saved properly when it's in the database. It's saved, the application can do what it wants. It's when it's saved the database I consider it done and working. The domain model is really fast for building domain first, thinking in objects and getting that saved from the database. But there's some places where it's just not going to work for you. If you've got a huge database system already with a DBA that runs it all and tells you what tables you can have and keeps control over your interfaces, then it's going to be hard. It's also going to be hard if you've got one big database and then lots of little applications built on top. If that's your architecture, then it's going to be hard to pick up. It's not saying you can't design the bits that talk to the database in an onion architecture way, but it's going to be much harder because onion architecture really is about domain first. Obviously, if you've got lots of code in stored procedures, it's going to be hard. We try and avoid stored procedures now. Stored procedures are fast. In some cases, you will still have to fall back to them. But there's a lot of problems in maintaining stored procedures. It's very hard to write unit tests on them. It's hard to keep track of them in source control. All these things that they are the fastest way of manipulating data in the database, but if you want to move them into a domain sphere and test them, in most cases, it's the developer time is more important than the actual runtime of your application. Okay, so that's covered a little bit of an introduction to onion architecture. And what I'm going to cover now is a few entity framework concepts and really introducing how you can use entity framework to implement some concepts of onion architecture. And I'll quickly run through these slides because I'm going to show you all these in code in a minute. So really the most important thing to understand about entity framework is the DB context. Everything that happens with entity framework happens in the context of this DB context object. The DB context object is a thing that sits, loads and saves your items and keeps track of the changes on the entities you make. So what it definitely isn't is just a layer, a standard data access layer between you and the database. It loads entities, holds onto those entities, and keeps track of what's been happening to those entities, and then saves it all at the end. So if you're still thinking in database terms like create, update, delete, you can sometimes trip on your own feet. So when you load an item, an entity, into Entity Framework, it has a bunch of different states. Added means you've got a new object, it's not been to the database before. you've put it into your context. So when you save it, it'll get saved. Unchanged is I've just loaded something from the database. It's now inside my context. It's sitting there, it's tracking my changes, but I haven't made any changes to it yet. Modified means it's in the system, I'm tracking the changes, and I made changes to it. And deleted means it's in the context. I've deleted it, but it's sitting there waiting to be deleted on the actual save changes call. There's actually an extra one that's really important that I missed off this slide, and that's detached. Detached entity is when you've loaded it from the database, it's in your context, but then you've closed that context behind it. So now you've got an entity, it's got its properties set, it's been loaded from the database, it's in memory, but its connection to the context that it came from and the database that it goes back to has been severed. And that's quite important when you take a look at lazy loading and dynamic proxies, which I'll explain as I do the code demonstration. And context management and code first migrations I'll also show you in the code. So let's move on straight to the code demo. Okay, so I'm going to start by designing a pretty simple object model. And the reason I picked these things is because they're pretty easy to understand. Most people have been to a school, so they understand the kind of thing we're talking about here. So we've got a student record that represents a student. We've got a school record that represents a school. And then if you want a student to join that school for a certain period of time, they have an enrollment record. And I really like this notation as keeping it as simple as possible. It means one student can have many enrollments, like one for this year, one for next year. If I change schools halfway through the year, I have 2 enrollments that year. Each school has multiple enrollments, so multiple records for each student. And so there's a student to enrollment is 1 to many. School to enrollment is also 1 to many. So let's take a look at how we go about modeling that in a domain in code. Okay, so to start off with, I have got a project. And inside that project, I've got 3 classes. One for enrollment, one for student, one for school. And if I look at the enrollment student class, you can see I've got a couple of things here. First of all, the most important field is the ID. That is necessary in order for Entity Framework to really be able to know what object you've got. It's possible to set up Entity Framework with compound IDs and various different primary key schemes, but it's complicated. You're much better off if you can, and you're not trying to work with an existing database, just running with an ID and let Entity Framework handle those IDs. So it's got some pretty simple properties: name, first name, date of birth. And here's the important one. So to map a one-to-many relationship between student and enrollment, we just do it as a collection. And that could be a collection, could be iList. It's pretty much an I-enumerable. Entity Framework will see that and understand that that means I want a one-to-many relationship between these 2 entities. And I've made this one virtual. Actually, I used to be a Java coder for quite a while, and everything's virtual in Java, so I quite like the idea of everything being virtual. I'd like to see that go. But virtual means you can override that collection, which becomes very important later. So I've taken this, this very simple model, and then I've wired it up to Entity Framework. So let's have a look at that. Okay, so the first thing to look at when you're looking at Entity Framework, here is the DB context. It's got a couple of basic constructors to get wired up to my thing. Then where I reference those classes, those entities, inside my DB context is there. So that means I can go context.student and get a iQueryable that lets me work with my students. Context.enrollment, again for enrollment. The next bit I've got is this line of code here. What this does is it will load configuration from this current assembly. That's pretty useful to be able to add files and have configuration in multiple places and just get it all wired in. So there's a couple of ways of setting up your configuration. The very first thing you can do is Entity Framework uses what's called convention over configuration. So by default, you give Entity Framework a value like this one. It'll still pick it up and do things with it without any configuration at all. You don't need to tell it anything. It'll try and make a sensible default and work with that. In this case, if you've got a string, it'll convert that string to a varchar max. So if you want to have more control over what Entity Framework is going to build in the database for that value, one thing you can do is attributes, or attributes, depending on your pronunciation. So attributes are one way to configure, but what I don't like about attributes is that they're starting to break away from our rule of not having any dependencies within our code. My name in real life doesn't really have a limitation. Unless I've got a really sensible name, it's not going to be 1,000 characters long. But that's really an issue to do with the database, not an issue to do with my model. So if you are using attributes to start configuring your entities, you're starting to break your rule of keeping persistence details out of your domain entities. Luckily, there's an alternative way of configuring, and that's the Fluent API. Okay, so when .NET 3.5 came out, that's pretty much when they invented LINQ, or brought in LINQ and Lambda expressions. For me, the most important thing about Lambda expressions was a new way of adding metadata to classes. I worked for a long time doing ORMs and stuff in Java, and pretty much you had two ways of adding configuration to a class. You could add attributes, which works really well. It's there in place, it's strongly typed. But then you start polluting your classes with the configurations. You can't add configuration outside the class. Or you could use XML files. Now, there was a time where everything was being done in XML. I'm old enough to remember that. But XML files are really big magic strings. I remember working on projects where you spend more time editing XML files than you did in the code. And the problem with XML files, they're not compile typed, it's just a massive magic string. So when LINQ came along, we've suddenly got this really powerful way of adding configuration to items and classes, but still in a strongly typed way. This is IntelliSensed, and it's also strongly typed. So here's how I've set the property to have a max length of 222. So if you want to do Onion architecture with Entity Framework, there's your first rule. Try and use Fluent validation, so Fluent configuration, over attribute configuration. So that's your setup, that's your configuration. The next thing I'm going to show you is the initializer. So I've got a little factory class I've created to kind of get my, basically get my context, get instances of my context, and I've also wired up an initializer. So initializers are little bits of code that run when you first tell the system, give me an Entity Framework DB context. Now there's a couple of initializers you can use. In this one, because I'm doing some tests, and I'm going to actually run some integration tests in a minute, I'm doing a configuration initializer called drop create database always. Now in real life, you're not going to make any friends if you turn this on. Because what it does is every time you ask Entity Framework to start up, it'll wipe your database and give you a clean one. What this is very useful for, though, is the really early days in your application when you're still not quite sure what you're going to do. You're not quite sure where you're going to put things. Is this one-to-many? Is this many-to-many? Oh my God, and you're trying things out. So that's when you turn on drop create and you just try your context out and move things around. And I'd probably work for pretty much your first kind of few weeks or few months, depending on the size of the project, with this drop create turned on. And then when users are starting to do some acceptance testing, when real people are going to log into your system and start clicking around and expect to see the same data they put in coming back, that's when I'd probably switch to migrations. It's not all dreadful though, because when you've got your drop create database always, you have this seed function. So what you can do in your seed function is set up a few test objects and prove that things work, give you a base amount of information to work from. And you can fill this with as much stuff as you want to give you a kind of baseline so that when you start your app, it comes up, all the entities are there, and this is the initial sample of test data. So to then demonstrate this, I've created a few integration tests. So here's a very simple integration test. I've written it in BDD. I won't go too much in the details, but BDD-Phi is a library that lets you write tests where the actual function names kind of document themselves. So all I'm doing is loading a context, then inside that context I'm loading the students, and then I'm asserting they've got some students and there's some stuff in the database. So let me run that, and then I'll be able to show you what it's built. Okay, that ran. So now I'm going to open the database and see what that did. Okay, so our 3 tables that we're expecting have been created. So all this was dropped and created just then running that one piece of code. There's 4 lines. Open, give me a context, query the context, make sure it's not empty. And that seed ran, the configuration ran, it read the model state from those domain objects and then generated this. So we've got sensible primary keys. Those primary keys are identity columns and integers. We've also got the expected columns. We've also got, because enrollments is the one that holds the many-to-many relationships, that has the foreign key IDs as well, pointing back in the other direction. Those are all sensibly set up, as you'd expect. And also, everything that's set up as a relationship also gets given an index. So the primary key has an index, and also the 2 relationships have indexes. So most of the time, that's exactly what you'd want to happen to represent that model in the database. So with not much code being written, and just with a simple, here's an object, here's a collection of other things to object, you're getting a pretty useful database out. And I've worked on plenty of systems where you had to do this by hand and you'd forget the index or you'd forget the foreign key and then find yourself in trouble. So overall, that's going to save you some time. So that's the first demo. I'm going to move forward in time. Bear with me. So what I've done is just grabbed a new tag from GitHub, so I've actually saved lots of instances of working code and moved forward to the next thing. Because what I've got next is I've taken that basic entity framework, and now I've turned on entity framework migrations. So entity framework migrations is the tool you use when you're ready to get rid of your drop create always, you want to hold onto the data. What entity framework migrations will do is from your model, keep track of the changes you've made to your model and then generate code that can basically make runtime changes to your schema to move your database forward to keep in sync with your model and configuration. So what we've got here is initial create function. So the first time I turned enable migrations on, and that's done through a PowerShell script inside the package manager console, it looked at my model and created this. And it's got quite a useful little almost like a DSL for manipulating your database. You've got create a table, add a foreign key, and I find this in general nice to work with and write in raw SQL. So everything you're looking at here is generated. What it generates is an up function that applies your change and a down function that backs out your change. The down function is actually really useful. But what you can also do is at any point you can come in here and change these things around. So to demonstrate this a little bit further, I am going to add a new entity with a many-to-many relationship. So, new class. I'm going to call it a course. It's public. So the first thing you need is an ID. And give it a name. And then I'm going to give it a list to each student. So each course collection of type student get set. So that's my new entity. I am now going to put the corresponding reverse relationship between course and student. Next thing I need to do is add that reference to my data context. Sometimes ReSharp is too clever for its own good. I need to give it a name, that's right. Okay, I think that's everything I need to do. Okay, so what will happen now, if I were to try to run this against the database, it wouldn't like it at all because my model does not match what's actually sitting in the database. So I may even actually do it. No, I won't do that. I'll move forward. So what I will do is I will create a migration.
Is there any reason that for the courses you didn't put virtual?
I should have put virtual, thank you. That was in student. I'll show you that. It's more to do with lazy loading, which I'll show you later. But you can put virtual for lots of things.
Why don't you want to override the other properties?
Yeah, you can put virtual there. By all means do. There's a specific thing with dealing with collections that virtual is useful. And I'll show you that in a minute. If you want to use lazy loading or not, basically. And I'll show you that in a minute. So let me run the migration. I'll lock that open, click this right. So it's adds migration. I'm going to give it a name. You've got to tell it where the project is containing your DB context. So I'm not used to this keyboard. Clearly. Oh, come on, shift. I'm only going to do this once. User group demo dot vanilla ef dash startup project name. Is that a space there? No. SSW dot Data Onion dot user dot Okay, so what just happened there is we've now got a new class in here, and it's picked up that I've got a new table called courses, and it's created that table, added the field, but then it's realised that because I've got a collection on student pointing back to course and a collection on course pointing back to student, you can't manage that just with two tables. If you want to manage a many-to-many relationship, you've got to have an intermediate table in the middle for that relationship to work. So it's then gone and created a table just to hold that relationship. So let me run this now to actually rebuild the database.
So Brendan, this migration package, I mean, this is something that comes built in with Entity, or
Yeah, it's with Entity Framework, yeah. This is all Entity Framework I'm showing you first. Okay, let's have a look at that database.
basically transfers domain model into third normal form tables pretty effectively.
Yes, yeah. And if you want non-third normal form, there's nothing stopping you going in there and editing in what it's made for you. And you can, change the configuration quite a bit. But the default is actually what you're going to want most of the time.
But what happens if you got the reverse, if the database schema got modified?
It doesn't really matter because I'll show you how that works in a minute. So obviously if someone changes the database around too much and there's an expected field there that Entity Framework thinks should be there, it's going to fall over and give you runtime errors. There's no way around that. But the way it works is not the way you'd initially think it would. So it's got this table called migration history, and what that shows is a history of the migrations that have been applied. You can see you've got what the name was, some stuff about it, and you've got this little blob of data here. That's quite important as well. But looking at the table here, we've got this student courses table created, and it's it has it's got a compound primary key consisting of the two foreign keys going back out to the relationship, so that just models the relationship between students and courses. So that's a many-to-many relationship handled just for you by Entity Framework. And all you've got to do is just add a collection in both directions. So when we look at how it works, the key thing is you can't just go and create one of these classes. You have to use the add migration script to build your migration, and the reason for that is what's happening here. You see we've got this pretty basic looking, pretty nice to understand class going on there, but what you've also got is this designer file. This designer file has a resource file against it, and this resource file has this blob, this big chunk of binary data that don't really know what's there. What that is a snapshot of the model at the time you generated that migration. So it takes all the things in your model, all the classes you've got, all the relationships, all the configuration into your framework, and it streams them into this binary blob. then later on you make changes to your model. What it does is it looks up and reads your model, generates its configuration, and creates a new blob and sees that your blob is no longer the same as the previous blob. So when it does that against your database, because your database has a copy of this blob, it knows that you've changed and you need to run a migration. When you create a migration, it unpacks this blob to get the previous model state, then uses that to work out what changes it needs to make. So the key thing here is to make its migration to the database. It does not read the database. It reads this blob. So you can make a change to your database, and if it doesn't break it, it'll carry on, but it will look at this blob and use this blob to work out what's going on. Now, one issue you can have is these series of blobs need to be pushed against the database in an order, in the exact order they were created. So if you've got two developers, one of them makes a migration, and before he checks it in, but at the same time someone else makes a migration and checks that in, the system can no longer replay that list of migrations. So we generally say the last person to check in is the person who has to fix any problems. Like if you have to merge it, you check in last, you've got to sort out the merge. If you check in last with a migration, you've got to sort out the migration. So what you have to do in that situation is just back out your change, and you can, because every single migration has a down as well as an up feature. Run the down feature, get to the point before the other guy made the change, apply his change, and then run the add migration script again to generate not from the blob you'd done it, but from the new blob, and then apply that change again. And the first couple of times that happens, it's a bit scary. It's like it's broken and you don't know how to fix it. And I know quite a few people that had this happen to them and went, oh, I'm not going to use Entity Framework migrations again. It's too hard. But once you've seen that and worked out that and moved that back and forward, you get used to it. And generally what we do as a team is just ping on Skype or on Slack that we're about to make a migration and organise it that way. Sorry?
Target tables will be straight away from the name of the class?
Yes. So it basically, when you look at this migration, let me show you the migration that we just made, this one. All these names are based on the class. So you've seen all the configuration I had to do to make it generate that. It read my class name, and from the class name, it came up some sensible defaults. It called it db.student courses. It called it db.courses. That's a name. It's got ID and name in there because that's the values I had inside my class. And it will do that automatically. If you don't like what name it gave you, then you can just change it in the configuration. So it's configuration by convention. You don't like something, you can just go, let's column name. That's it. That's all you need to do to actually override that configuration and make it say something else. So now you have a last name inside your entity, but it'll have the column name surname when it's generated. In fact, I won't generate that migration, it takes too long. Sorry?
The add course CS file that you have, that is used for the migration. Could you go to the CS file, please?
The CS file? Yeah.
Under migration.
Yeah, so this one, that one's generated by the migration. Yeah.
What happens if I mess around with this one? Does it wanna?
Yep, you can mess around with it, of course you can. You can mess around with it, but if you mess around with it, Entity Framework doesn't know that you've messed around with it. So if you mess around with it in a way that breaks the migration, so that the database you create from that migration doesn't match up with the entity configuration in the memory, it's going to fall over. It's going to try and query a column that doesn't exist.
So if I change the name here from DB student courses to DB student courses?
No, that won't work. Yeah, that will break it because in the configuration, it's still thinking that it's named something else.
That would be a compilation error?
Yeah, it would be a...
Migration,
It would run the migration and create that name, but then when it tried to use that database, it would fall over because Entity Framework the configuration Entity Framework thinks it's called something else. So if you want to change it, make the change configuration and rebuild the migration.
So what would you do if you want to see a new table with, like, say, master data? Like you create something called like something status, like student status, and it has a bunch
Yep,
of
so you can seed that up. So you can do that in the seed function. So with Entity Framework migrations, you've also got a configuration file here. And at the end of the configuration file, there's a very familiar seed function, where you've got pretty much the same as the previous initializer I showed you. Yeah, so you've got a seed method in there, yes.
You don't
Yeah.
put it in the app courses.
Sorry?
You don't put it in the app courses, that's why I'm
No,
thinking.
no, you can do. I mean, there's nothing stopping you. I mean, you could inside here read from an XML file, but generally you'd put it in the seed function. You can do both, actually. It doesn't actually hurt to put it in here. One good thing about putting it in here is it's guaranteed to happen when that migration happens. One thing about the seed function that happens at the end of migrations is the seed happens once all migrations are done. So the seed has to work against, and the seed runs against the context, the DB context. So if there's something in the context in your seed that was written against your database, 3 weeks ago, and your database has changed a lot since then, it might break. Where if you put it inside here, it's always going to work. It'll be consistent with the database at that time, but you don't have your context to use to put the data in. So I can put data into the seed by doing schools.add. I've got actually using Entity Framework to put my data in as objects. In here, if I wanted to initialize it, I have to use SQL, because this is a lower level technology. So let's move us forward in time. I've made changes, so all I need to do is just back this out. So bear with me a second. Code, live, let's get rid of that. Let me. Get it again. Okay, all the example code is available on GitHub. What version we're up to? We're up to version 1.4. Show the laser loading. Okay, so that's Entity Framework code for its migrations. Let's move on now to show you some of the features of Entity Framework. And the very first thing to understand is lazy loading. Okay, so here's my lazy loading test. I'm going to start with a new database, and I'm going to put some enrollments against my record, and I'm going to close that context. So that's done a piece of work in a single context there. Then a later context, I'm going to do two things. I'm going to load my student record, and then I'm actually going to move from that student record and actually query for the enrollments collection against that student record. And I'll put a breakpoint right here so I can show you how that works. And this is where the fact that this is virtual becomes very important. So if I try and debug that test, run. Loading tests. Why aren't you running my test? Inconclusive. Test not run. Okay, it looks like it's doing something this time. Okay, so we've got to the point we've just reloaded this Brendan object from the database. And so what's important here to understand how Entity Framework works is what the deal is with this object that's been loaded. So this object is loaded, it's in memory, and ostensibly is of type student. But if you look at it itself, you can see it's not of type student at all. It's of type system.data.entity.dynamicproxies.student. Some big thing. So what is that? Well, that's what's called a dynamic proxy. A dynamic proxy is a way of taking an object and injecting behavior into it. It's been used quite a lot. It's used in RMs quite a bit. It's used by nhibernate. It's used by Entity Framework right here. It's also used by Spring. Spring, if you remember Spring.net, that's not been used much, but that used that a lot to have all kinds of things like that used to use that to do AOP, aspect-oriented programming as well. So what happens is when you ask Entity Framework for an object of type student, it'll create that object and actually give you back a new class that's a subclass of student with its own features injected in. Now one of those features is lazy loading, which is turned on by default. So when I load this Brendan object, it loads me all the basic properties, so name, first name, date of birth. What it doesn't then go on to load is the enrollments. What it does instead is it uses the dynamic proxy to put in a little stub for enrollments. Now, when I then go Brendan.enrollments, that's the time it goes, oh, you do want the enrollments, I will go and fetch those for you. If I have a second query, and goes and fetches that collection. So it's a very powerful tool in that you can load something as an entity without knowing exactly what you want first up, and then if you then later on happen to ask for it, it'll then go and fetch it. It's powerful, but it's also very, very dangerous, because if I've loaded 1,000 records and I'm going to loop through those records, and every time I loop through that record I'm going to go and load enrollments, it's going to go, oh, you want to load enrollments? I'm going to fire a query. Oh, you want to load enrollments? I'm going to fire a query. So that you get what's called the n+1 problem. So if I want to load an object, and that's, I want to load 5 objects, and it's going to have 5 collections, I'm going to have n+1, 5 + 1, 6. I'm going to have 6 database queries running against the database. So it's powerful, it makes development much quicker, but you need to be aware that's what's going on, because if you get that wrong, you can shoot yourself in the foot.
And sorry, what is the way around on that?
You can do, there's a couple of ways around that. Yep, you can use lazy loading, or you can turn it off. You can also do eager loading, where you specify up front with your query what it is you want to load. Or you can have lazy loading turned off, but then manually load the references. So I'll show you those examples next. So here is my next test. So what I've done here is pretty much the same thing. I've set up some enrollments. I've then loaded my record. But before I've called Brendan.enrollments to actually load that collection, I've actually closed the DB context that it came from. So inside this this is where my DB context is. I've closed it. So let's see what happens when I try and run that. Failed. Let's have a look at this error message. This error message you get here is object disposed exception. The object context instance has been disposed and can no longer be used for operations that require a connection. So what this means is I've got this dynamic proxy that Entity Framework gave me because I had lazy loading turned on. But then when I tried to use that dynamic proxy, try to actually follow that navigation property, it's now disconnected from the database, disconnected from its context, and it can't run a query. So it can't load those enrollments. So it just falls over. So what else can you do? Well, one thing you can do is you can load a context. You've got a context, you load an object, close a context. If you get a second context, you can also always cause context.attach. So that will attach this entity to the new context. Now it's connected to a database, and if I call Brendan Not Enrollments, that'll work.
But then you're opening two different connections.
Yeah, you are opening two contexts. Yeah, two contexts. The actual one, and there's presumably two database connections as well. But the database connections are pooled, so we don't worry too much about those. But yeah, you're creating two contexts in that situation. Yeah. So there's basically what the point I really want to drive home is just how important context management is. Managing that DB context. How long are you going to keep it alive for? I'm going to keep it alive for a long time. But if you keep it alive for a long time, it's going to fill up with memory. Do I keep it alive for a short time? If I keep it alive for a short time, then the entities I've got from it will be detached, and I won't be able to do so many things with them.
Why can't I have it index from high disposable and then proper disposable whenever
Yep, you can actually make this is already disposable. The DB context is disposable. Yeah, so I'm actually using it in a using block here. Yeah. Yeah.
Can I have a question here?
Yeah.
If let's say we have some collections,
Yep.
and because of the lazy loading, if we don't access that collection,
Yep.
it will not load from the database, right?
Yep.
So my question is, what will happen if, let's say, I want to make some changes to the basic property, not the collection itself,
Yep.
and after that I want to do a save changes to the database. So what is the behavior of the saving? Will it drop the collection?
No, it does keep track. So if you haven't loaded the collection, it knows you haven't loaded the collection, so it won't even bother looking at that collection.
No
Yeah.
impact to the
No,
database?
no. In fact, that's exactly what you want. If it's lazy loading and you don't load it, then it's fine. It'll ignore it. So that's the key part of that. Otherwise, you'd load everything up front. So the whole point of lazy loading is you don't know you're going to want it.
But my worry is,
Yeah.
If you don't load, then that collection property is now. So when it's saved back,
Yeah.
you know whether it dropped or not.
Now that's not a problem because of your dynamic proxy. That collection isn't null. It's not going to try and write null. That collection is whatever magic implementation entity framework puts in, so that when you ask for it, it will load it for you. So it knows that hasn't been touched and it will leave it alone.
Okay, thanks.
There's one more test. I've got it somewhere. Okay, the next version. So lazy loading is generally quite useful. I like it. It depends on your workload. If performance is a really key component, then probably turn lazy loading off because you're losing control of when things are being loaded. Yep.
Even like when you don't need to do more than the 2015 is considered an antipattern.
What's that? The lazy loading? Yeah. In modern DDD, it's an anti-pattern. Yes. Yeah.
So basically, if you're using, if you're loading anything, it's going to go through a repository.
Yes,
So
yes.
it's fine, then you
Yeah.
usually either.
Yeah, that's right. Yeah, I mean certainly there's much talk about turning lazy loading off in Entity Framework 7, certainly by default. They haven't implemented it yet in Entity Framework 7, but they're thinking of actually in Entity Framework 6 and previous versions, it was on by default, which gave a great developer experience, but had a lot of developers shoot themselves in the foot. I want you to, basically you have to look at the problems in front of you and know that this is an option you can turn on and off and understand the ramifications. If I have it on, what do I have to do? If I have it off, what do I have to do? But certainly, yes, it is considered an anti-pattern. But the word anti-pattern just means something that lots of people have been doing when they probably shouldn't be. It may be a pattern that's still good for you in your particular circumstance. That's up for you to make a decision, basically. So with that in mind, how do you then work with lazy loading turned off? Okay, so if you start out with the context and lazy loading is off, and you load an object, and then you go and try and browse that navigation property with a collection, then this property will be null. That still won't cause you a problem saving it back, but it will be null. An entity framework understands that it's null because it won't freak out and try and clear your collection because it's got some smarts around how it manages the lifetime of that collection. So what you've got there, it'll give you null. So how do you actually use something? How do you actually, well, if you did want that, well, then you use what's called includes. So here's I've got quite a complicated example here just to show you the way to hop through quite a few different properties. So I want to load a student and I want to include all the students' enrolments, I want to include the students' courses, I want to include the schools that course belongs to, and I want to find the person myself. So each of these takes a lambda expression, which is the path to the thing to include. And in this case, I'm also going from a single object to a collection and selecting something the other side of the collection. To do that, you have to put this select in the way.
What happens if you need to go one more level deeper than that?
Yeah, just keep on going, basically.
Like
Yeah, keep on going forever.
Include where the courses select them.
Yeah, yeah. If this was if there was something under school like school dot, I could even go from that school to get all that school's enrolments. But obviously, the more stuff you add, the bigger and scarier. I mean, this looks nice and neat. The query that's going to be thrown by this in actual SQL is going to get bigger and bigger and nastier. So I could go here. I've got the school, so I then want to go dot select. Yeah. Dot students. Yeah. Oh, I've got courses. But yeah, you can keep going basically. Actually, school doesn't have any things going back to it. Has it got enrolments? No, it doesn't have enrolments. But if that had another thing, you can keep going. Yeah, yeah. If school had a collection on it, I could then go to that collection and select and keep going. But obviously, at some point, you're going to have your whole database coming back into your memory, which is probably not what you want.
But Brendan, my question is, when we're done loading, what does enrollments actually have for when only one enrollment or all enrollments?
That'll be all the enrolments that are against that student. So it's still following the pattern. So it'll look at enrolments has a foreign key pointing back to student ID. So it'll select where that foreign key is set.
These are all effectively left joins in the table.
Yes, that's right. Yeah, yeah. These get turned in left joins. Yeah.
The student, all the student's details.
Yeah.
Duplicated.
Yeah. So yeah, this is how you load a navigation property. If you start doing too much, you're going to start having problems with performance.
So left join basically. So because in this case you're saying I want because this student can be enrolled in multiple schools.
Yeah.
And you only want the enrollment for a particular school, for example.
Yeah, yeah. It's used to school.enrollments. I haven't actually got enrollments.school. Actually, I thought I did, but I don't. No.
Excuse me.
Yeah.
Can you ask for an object with the lazy loading turned off? With in the oral context is turned on, but for
Yeah.
that particular object you want it everything.
It's a global setting on the DB context right now, so you can't control it. If in Hibernate you can. Laser loading in Hibernate is a per navigation setting, but in Entity Framework it's a global setting against that DB context.
So you can't say okay.
No,
for
yeah,
this particular line I want
yeah,
for student give me everything.
yeah. No, it's missing some of those settings definitely.
You could turn it off, dump this stuff, and then turn it back on.
Yeah, I'm not quite sure how well that works. Yeah, I've not tried that, but feel free to give it a go.
You wouldn't do that because you're trying to kill it out of it.
Yeah.
So over here you have it set to false, but if we set it to true, that will still eager load that one.
Yes, yes. So the other thing is, even if you have entity laser loading turned on, you can always use the include calls to eager load for that particular query. So this include will work either or. So that's a laser loading. The other thing you've got that you can do is, even if you have failed to eager load something, and you've got entity laser loading turned off, you've also got the ability to actually manually load a collection reference. So context.entry for the object actually gives you back Entity Framework's actual record for that entity item. From there you can track, you can also see what the original values were and the modified values, so you can see what changed. There's quite a bit you can do here. You'll also read what state it's in. But then from here you can go collection, give it a lambda to find that collection, .load. That will load that reference. That's useful if you're doing something where you've got a fairly recursive design, like you've got something that then can recurse down. You can maybe, I wouldn't do it too often, but sometimes you just need to recurse, and so that lets you load those steps. Bearing in mind that every time you do this hop, you're firing a database query. But sometimes that's just what you need to do. So my next thing I'm going to show you is inheritance. Okay, so I've added a new type called activity. But in this case, I've got a couple of different types of activity. I've got an in-school activity, which happens inside the school, and that has a classroom property. I've also got an outside school activity, and that has a name of the person who's responsible for that activity taking place outside the school. But they're both of type activity, so they both inherit from this activity type, and that's got an ID and a name. So let's see what Entity Framework does with that, first of all. Now there's a couple of different techniques for dealing with inheritance. Two main approaches. There's actually three, but I can't remember the third on the top of my head. But there's pretty much table per type and table per hierarchy. So what happens with table per type is each of those three types you've just seen, the parent type and the two child types, get their own table with their own set of values. And then we use a kind of shared primary key to link all those different records together into one entity. That's kind of more normalized, but that's also going to be slower because it's got to load things from different places. Your other approach is table per hierarchy, where you've got one table, but that'll have all the records of the various types of activity in that one table. So in that case, you'll have, for example, your in-school activity records will have null against the responsible person table record, and there'll be a discriminator field in that table to tell you which actual type it is. So depending on your load and your actual what you're trying to do, both of those, generally I use the, well, first and foremost, try and avoid using inheritance if you have to, because it is complicated, and you know, one thing with inheritance, when you first kind of learn it, you try and do everything with inheritance and end up with this ridiculous tree of objects that you can't then work with. But sometimes you just need to use it, so by all means go ahead. So let's see what was built for that database. So we've got an activities table, which has the core properties of that activity. We've got a in-school activities, again with the properties and the shared ID, and then the outside school activities. So let's see that in the test. I can show you some things. Okay, so now we've put these three activities in the system, we can actually query them in a couple of ways. If we just query straight, it'll just query all the activities that we've asked for. But we can also query for specific subtypes. So the of type extender will work on that and give us just in-school activities or just outside. So from that structure, we can just query give me all activities and make an aggregate count, or we can query all activities by their type. So potentially useful. Okay, that kind of completes what I was going to show you about Entity Framework. the next section, I'm going to talk about what we've built on top to kind of take the base side of what Entity Framework can do and make it a bit more Onion architecture-y. Obviously, I've already said we're not doing full-blown DDD. That takes these concepts and takes them much further. Let me run through my next few slides. So one of the key things you're looking for really is what's called persistence ignorance. The fact that your domain models don't know much about the database that you're sending them to. So to achieve that, I think it's much easier using code first than database first. And in fact, with the new versions of Entity Framework, they're not even bothering with database first anymore. EDMX files are going, as so is the the database first pattern. Doesn't mean you have to have your database first. You can still write code first style code. I think that you probably change it to Fluent configuration based or something, because you can still now, there's new tools coming out that will look at your database and generate a code first style set of entities and a code first style set of entities and configuration from your database. But really, if you're doing kind of domain sort of first design, then code first is the pattern that best fits that model. The next thing is obviously, yes, implement your domain as plain old CLR objects. And the best tip really is using the Fluent API, because then you're adding configuration without putting that dependency inside your domain models. Now, I'm hoping the pizza comes soon before I move on to the next section. Anyone on the pizza? Because it's a good break point now. Actually, should we just break now because the pizza's due soon, and then come up to part 2?
Well, let me find out exactly.
Okay. Okay, so when working with entities in Onion architecture, a common pattern you see is called the repository and the unit of work pattern. So what the repository is, it's an object for just restoring and retrieving entity of generally a single type to and from the database. So going back to our architecture model, pretty much the first thing you put around your domain entities are your repository interfaces, and that's pretty much how you get and save them from whatever persistent store you want. One of the key points is that obviously when you're building against interface, you can change the implementation without changing your code around. In reality, most systems you won't go and change. No one's going to turn around and swap out from SQL Server to Oracle, for example. I've done it, but not many people do. But there's a lot more you get with that as well. Because you're using these repositories and interfaces, you can test. You can create mocks and do unit tests against those mocks. You can also it basically gives you a place to put your code. It's a more structured way of working. So the pattern we've been using, and generally I think it's a pretty good one, is that we use a repository for a single object type. Then if you've got a piece of work that has to talk to multiple objects, like actually completing an order, where you're working with order items, you're working with other things, then that moves into the business layer. So as soon as you need to talk to more than one entity type, don't put that code inside a repository, put that code in the next layer up. So you keep your repositories clean, focused on one thing. Your business logic layer is then the things that groups them together. So working with that as well, you're working with code, it's making changes to your entities. The unit of work pattern is really how you wrap up a piece of work into a single package, and then when you're finished, save it or abandon it. It's kind of like a transactional model where you, and so the real job of the unit of work is I'm making changes to multiple entities, and using multiple repositories as a result. So once I've finished making my changes, I'm going to wrap that up into a single unit of work and save it. Okay, so at SSW, we took a look at Onion architecture and thought, yep, that's what we want to do. And we were working with Entity Framework, and that was good too. So we were looking for ways to actually take Entity Framework and build a working repository implementation with it. So had to decide on what kind of features to have. So the first thing we have to decide on really is leakiness. By leakiness I mean if you write a piece of code that kind of encapsulates and wraps another piece of code, at some point implementation details of what you're working on have to leak through at in some level to the actual code. Obviously a perfect repository implementation would have no leakiness, but then you'd have to build every single thing it did by hand. So you can have a repository where every single function you call in that repository you've written by hand, and it's totally encapsulated and it's well understood. But that's going to take a long time. You're going to lose all the great features you've got in Entity Framework for dynamic queries via link, for example. So what we decided to do was expose as much as we could to use the features, but still have it usable. So the very first thing we did is we exposed our queryable interface. I don't think that's too controversial because pretty much every data layer these days, say you're using RavenDB, you're using in Hibernate, you're using Entity Framework, all the new non-SQL systems that are coming out, pretty much they'll give you an iQueryable interface to work against. So that's still, even though you've been given an iQueryable, you'll find there's things you can call on Entity Framework's iQueryable that you can't call on, well, stuff you can call on, say, an iQueryable built of objects, a list of objects, versus the iQueryable you can run against Entity Framework. There'll be some functions you can do against a list of objects that you can't do in Entity Framework. It just doesn't have a corresponding implementation once you move down the layer and actually try and turn it into SQL query. But it's still a pretty good, pretty powerful pattern. You can still run dynamic queries and projections, which is the important thing. So the next thing we looked at was the realization that when you're working with Entity Framework, the most important thing is managing that lifecycle of your DB context. The other thing we found that Entity Framework itself is a little bit weird in how you configure stuff. You configure stuff with generics. I can show you an example of that actually. If I go to this context factory, if you're used to doing things with dependency injection, if you want to wire two things together, the best way of doing it is making it a constructor injector. So if this thing needs something, it'll ask for it as a constructor. If this thing optionally needs something, it'll have two constructors, one with the thing, one without the thing. Entity Framework, by contrast, has quite a few weird things where to wire up the initializer for this type of demo context, you've got to actually call this global function, set initializer, and then in generics hand in the type of the demo of the DB context you're looking for, and then give it the implementation. And again, here you're wiring things up by generic, saying here's this generic thing is a type, not the concrete type you're going to be injecting, but and it'll then go and call assembly, what's it called? It'll activate a create instance on these things to wire them up behind the scenes. So it's not very dependency injection friendly. So what we did was then basically take these and just make it a little bit more dependency injection friendly. So we've got a DB context factory who, using the single responsibility principle, all the DB context factory is in charge of is making new DB contexts. So I'll give you a DB context with the initializer set at the expect. Then the next thing we looked at is, well, we need to be able to manage a DB context, the actual lifecycle. So we created a second class that was in charge of managing the lifecycle of our DB contexts. The next thing we had when we were working, and this was pretty much a feature of the project we were on, as much as anything else, actually a lot of Data Onion is based around what we needed for our project. We just thought, actually, it looks quite useful for some other things. So after a couple of projects at a particular client, we took some of the code that evolved over time, over those projects, and turned it into a NuGet package, or a set of NuGet packages. So one feature we had in this project we were working on is we had a core database with our data in. We had a second database with a bunch of CMS data. So we had a screen on, there was forms over data, a bunch of fields, and then around those fields there's bits they could click and then edit the text surrounding that form. So we had those two databases, so our unit of work that we built supported multiple DB contexts in a single unit of work. The other thing we did to make it kind kind of usable is then all these resources we made them all disposable. So to manage the life cycle of this stuff, unit of work itself is disposable. So to manage your life cycle, you can either use a session per request type pattern or actually just call disposable on it directly. So that's one more thing I want to talk about with the lifecycle management. There's a couple of patterns for managing the lifecycle of your DB context. Obviously, the first one is using, do some work. When I'm finished, close the using, and it's gone. So for small pieces of work, and then if you've got other pieces of work, put them in usings. That's probably the most, the fastest system, because you're not leaving context lying around for too long. They're not going to fill it with memory. The one that's nicest to work with as a developer is the pattern we use called context per request. So what that is you start a HTTP web request. It only works for web applications, obviously. And then at the start of the request, or the first time you actually need to use the database, it'll create a context. It will then hold on to that context for the life cycle of that request. So at the end of the request, it'll close it off. What that's really useful for, if you load something early on in your request and put it in memory, but then later on you're doing a view, and in your view you suddenly decide you want to go, your person.enrollments, for example, then even way down in the view, if it's a later loaded item, it will go and fetch that object. So it's a good developer experience because stuff just works, but you've got to be mindful of the fact that you might have introduced an n+1 problem. You might cause problems with that pattern. So you need to understand that later loading is there and what it's doing. I think one of the common features, problems people have with Entity Framework is they install the default, they start using it, and they haven't taken the time to find out what's going on behind the scenes with these later loading configurations. So the other thing we were looking for with Data Onion is the fact that it was starting to get a bit wordy building all these repository classes. So if you want to add a new class, it has to get wired up to the DB context. We then need for each class, we need our repository interface, and we also need a repository implementation. And we started off, we were building this day after day, just working with building manually, and then we hit upon the idea of maybe we can generate some of this stuff. So that's exactly what we did. Good time for internet to die. Where's those 128 megs up and down now? Yeah, that's why. We don't own the whole thing. This is worth doing because I've got a picture that explains what we do. Come on. Okay, so what we do with SSW Data Onion, it's got a few things like I've explained, a few things around making Entity Framework a bit more dependency injection friendly, but the core of it is really, we'll read this collection of domain entities and then generate your repository interface, your repository interfaces, and then generate your repository implementations. What we then do is, all those are generated as partial, so that then you've got a space to go and put your code on top of it. So you've got basic CRUD operations, and I wouldn't recommend doing it, every now and then there's a CRUD operation or an operation you should do that Entity Framework doesn't do very well, or the default doesn't work for. You've got your extension point to put your own code. That's the key thing, giving you somewhere where something should go. There's plenty of examples on the web there where they use repositories and they show you a generic repository, which works. It does work, but you lose that place to put your own specific code. Where with this generated repository, every single class has an interface already made for you, has an implementation made for you. You just go in there and add a new partial at the same level, and you'll be able to extend and add your own stuff. So we've actually got 3 templates, a TT template for a chunky DB context. So if you remember in your DB context, you've got all those lines where you set a DB set for each entity type. That gets generated. Then we generate interfaces and repository implementations. So let's take a look at what that looks like in code. Okay, so we've got the same domain classes, pretty much unchanged. But then I've kind of left behind these old vanilla entity framework layers that I've been showing you so far. And we've got a new entity framework implementation. And then we've got a couple of new things. I've got this package here called data interfaces. I've got this package called dependency resolution. And then I've got some integration tests to show them all working. So as you can see, in order to enforce your and make it impossible for you to get yourself into spaghetti code, one good way is actually to put things in different projects, because a project reference is only ever one way. You can't put a project reference between 2 projects in one direction and then the other direction. So that's why we've put it this way, with a set of data interfaces in one class, in one project, and then the actual implementations in the other project. So what we do is when we actually wire up our code will have dependencies on the data interfaces. It'll be runtime configuration via dependency injection that actually tells us, yep, we're using that one. And that's what this package here is, dependency resolution. So whatever our main startup app is, we'll have a dependency on the domain, because everything does. We have a dependency on the dependency resolution package, which then does the configuration, and everything else is just the interfaces, and the actual runtime is worked out through the dependency resolution. Let's have a look at the configuration here. So what we do is we've got a couple of NuGet packages, one for generating interfaces, one for generating the DB context, and one for generating the repository implementations. So basically you've opened it up, you install the NuGet package, and you've got this configuration file. And you point the configuration file at where your domain model DLL is. You tell it the namespace, you give it the namespace of the repository you want to build. And then you've got this little func here that gives the opportunity to filter down your list of entities. So by default, it will go to your domain model DLL and load all entities that aren't abstract and not sealed. If you want more control over which things you want to generate a repository for, you can put it all in this function. So then if you rebuild, sorry? Yeah, I think it's to close and reopen it. That's probably me updating from GitHub in the background. And it's got itself confused. Let's see if it can bring it back.
I think the solution might have worked.
I might have done that, yes, that might have worked. I'll try that next. Yep, okay. So with this system in place, if you add a new entity model, you just go to, I think it's under build and transform all T4 templates, and it will pick up all those things and put them in there. So straight away, it's even less work than vanilla entity framework, because in vanilla entity framework, you had to go in and edit your DB context. This does that step and build you these libraries on top as well. So to see the code where that's used,
So where are the places that were generated?
yep, I can show you those. So if you go to generated, that's the configuration file. There's the TT file underneath there. And so we've got some core classes behind the scenes, and we pretty much just add a partial interface for each of these. So for each, that's the generated code for your interfaces, and here's the generated code for your DB context. As you can see, we've just added each of these, and then we've added the actual repository implementation. So the other thing you get are these base classes that actually have the basic CRUD implementation in there. So your gets, yep.
Why is there a enrollment repository? Does it make sense, or shouldn't I go through the student, for example?
Yeah, if you're doing DDD, then yeah, that's what I would do. So this is and once you start talking about DDD, you start talking about aggregate routes and saying how these are the core concepts. Like enrollment just belongs to a student, so you don't. Peter's outside. Yeah. Okay. Well, we'll. Yeah. So this is very much not a talk on DDD because that takes these ideas and takes them even further. This is really more about the features that NC Framework has that lets you step towards Onion architecture. And the Onion architecture we've been doing on pretty much a forms over data app. Certainly you can take this much further with a DDD pattern, and certainly we're looking at you could still use this and start identifying aggregate routes and only include repositories for your aggregate routes and move that way and still have this generate for those for you. But then you just have to start adding more, I'd expect to see much more being added to those repositories to actually handle in a smart way those relationships from your aggregate route. So pretty much to use this now, where we were, where am I? Yeah, so where we were getting hold of the context itself, what we're doing now, and this code looks a bit weird because I'm trying to make XUnit work to do integration tests. And the older version of XUnit had some stuff to wire up to the NC Framework, to dependency injection. This way I've just had to go back and actually do a service lookup. So instead of getting hold of a DB context, I'm now getting hold of the student repository as a dependency, and then I can just call a bunch of functions on the student repository. And they're pretty much similar to the way they were called on the context. So I will pause now because the pizzas are here, and we'll finish off after pizza. So one question I was asked in the break was a little bit about which dependency injection I use. I quite like Autofac, so I'm just going to quickly show you how Autofac is configured to set this stuff up. One feature Autofac has is modules. I think quite a few things have modules. I think pretty sure Structure Map has. A good thing about modules, the way Autofac does them, is it provides places to inject configuration. So I'm injecting a connection string and then using it later in my configuration. Now, I'll briefly run through here. I register a initializer. I initialize a DB context factory, and then I set up a DB context manager, wire it up to the unit of work. Then I've got an assembly scan that just wires up all the repositories. So every time I generate a new repository, it's automatically picked up by Autofac. So anytime it sees an iSchool repository, it looks for a school repository that sets up in any other class. Basically any class that ends in repository that's in one of these two assemblies will get picked up and wired up as imprinted interfaces. So moving forward, I'm now going to show you briefly just how you actually, on a day-to-day business, use this repository pattern. There's nothing, it's kind of a hello world example, really, but it is quite useful. Okay, so all this stuff with setting up Onion architecture, setting up your entities, your entity configuration, pretty much leads us to this one point where we can have a controller, and then that controller can just inject a repository and a unit work via constructor injection, and entity, that's all we need. Autofac will automatically wire that up to our configuration for us. So then if I want to actually use that, here's an index, I'm just going to get all the records. Here's a HTTP edit screen with a post, that'll just work. So I'll run this, and then I'll talk about what's wrong with this, because there are some things that are wrong with what you're looking at here. Okay, here's a basic UI, and I'll open up the view as well. I can click on edit to see something. Obviously I'm using Bootstrap, so nothing clever here. I'm not just looking to show the basic kind of hello world of using the repository. So inside here I've got the controller, inside here I've got the views. Okay, so my index here is just listing through the list of models that I got straight from the repository.get, and straight away you can see something that I've done that's wrong here. I've called student.activities.count inside a loop, which means what I'm doing here is I'm doing lazy loading, and I've got the n+1 problem. So this will work up to a point, but if I start to get lots of records, this is going to be far too slow. The other thing that's wrong with what I've done, because I'm binding straight to domain objects, is what happens when I'm saving is a bit unintuitive. If you look at this post, what I've got here is I'm binding directly to an entity type. But what I've got here at this point, once I'm inside this object here, is I've got something that looks like a domain model. It's the right type of domain model, but it's not a persistent object. It doesn't come from my entity framework. What it came from is the very clever model binder the web layer has, and it's basically read a bunch of read the form fields coming in and injected them into a copy or it's got an empty version of that object, which means I can. What would be dangerous is if I was just attach that straight to a context and save it, a number of weird things could happen. If I sent that out to the screen and I didn't have some of the fields set, they'd get wiped. Or I could get a duplicate saved because it hasn't looked up the record by ID. It just thinks it's got a new record with the same values. So one thing you can do is just load the entity by ID and copy them through, but it's not very clear what's going on here. I've got something that looks like the object, but isn't the object. So generally it's much safer to build view models. And one thing to remember is when you're dealing with the web, what you're doing is you're taking your objects, whatever they are, and streaming them to a big magic string. It's either a big HTML stream, and in the middle of that HTML stream you happen to have some input tags, and inside the input tags you've got a name and a value field, and that's where your data is. Or if you've gone in a step further and you're doing web API, then at least the object going out is got the same structure. So if you're doing web API, you kind of convert it to JSON, send the JSON stream out, getting a JSON stream back. But in all those cases, you'll tend to find that what works inside that magic string isn't always matching exactly what's going on in your database. You need to do some kind of mapping. So let's take a look at that. Okay, so what I've done here is I've built a view model. So the view model now covers what I want to see on my screen. So I've got a lot of fields that are the same, but I've also taken some of these lookups and turned them into actual integers. I want to see an integer on the screen. I don't care that it came from a lookup of a collection. So then generally what I do to map is actually build a mapper class. Now, what I hate about view models is having to repeat myself. Every time I sit down and type address 1, string, address 2, string, suburb, string, I die a little inside because I keep doing it day in, day out. And so I resisted using view models for a long time just because I wanted to say something once and once only. I want to say this class has these 4 fields. Here are the types. That's it. It's fixed. It's static. But the reality of having to deal with more complex types, I finally agreed everything should be a view model just because it's safer. Then when I was looking at view models, I tried a few mapping tools like AutoMapper and stuff like that. And although they work quite well at first for simple examples, at some point it just ends up biting you. At some point it's like, oh, you know, I wish I didn't do it. So now I've resigned myself to the fact I'm going to spend a bit of time doing boilerplate mappers. Yes?
Did you use this view model here
Yep.
just as a data transfer object or tightly coupled with the view, like in MVC? So because
Sorry?
Here it seems like this is here you have used the. Did you use this view model just to as a like data transferring like as a like?
This are you asking like, is this a DTO just for the web, basically?
Yeah.
Yes, that's exactly what it is. It's a DTO, and it only exists for sending stuff into a stream, a text stream, out to the browser, and for receiving that data back again.
Yes.
So it's kind of a DTO for web.
Yeah. So the thing is, now for that type of situations and for that requirement, we can use model concept rather than going for the view model, because view model is totally bind with our view, right?
So we can use what? Sorry.
These view models,
Yep.
and conceptually it's totally coupled with our view, isn't it?
Yes, we actually put that view type inside our MVC view. Yes,
Yeah,
is that what you're
in that
saying?
case, anyway, it's better to come up with different view model for each and every view, right?
Yes, I would generally do a
So,
different
yes,
view model for
in-
every use.
yeah, in-
Sometimes I get a bit of code reuse from my
Yeah.
views. Like there's a fraction of view model that works really well on a index screen, and it also works quite well on the edit screen as well. But generally, I do a view model per view. Yes.
Yeah. In your case, if
It's-
you take, say, if I want to use that student information in 2 different views.
Yep.
So what we can do is say for that ID and first name, last name.
Yep.
We can keep it into separate, not view model, separate model. Then we can use that model here. Then we can reuse it. Then no need to recreate that class.
I could actually use the model object itself in that view.
Yes.
Yes. So that's what I did show you. Yes, and that was my initial thing. And sometimes I'll do that, but generally at some point I regret doing it. Basically, for what you're looking at here, it's all very simple maps. You know, if you have it coming in from the model binder, it's not going to have any trouble dealing with what's coming in and mapping it straight to your domain object anyway. But as soon as you get more complicated, you do need to start thinking about models. Yep.
So what do you think about that bringing that POCO objects
Yep.
coupled with our table structure, bringing into the view,
Into the
view, because I saw in can you open that?
actually the previous example we did bind your domain object straight to the view. So that was the previous example. this new example is so that's possible, you can do it. This example is, what if you need a view model? So yeah, the very first example was binding straight to the model, and you can do that, and the MVC data binding is very good at taking all these fields that get injected as form parameters and turn them into a model object. It can be confusing because you're looking at this, you've got this object that's given you not from your entity framework, it's coming from your data binding system instead, so you need to understand that. And so generally that works, but you're safer doing view models because it's more explicit.
Because if you look at the Microsoft example, most of the example, they have, when you say example with the entity framework, they show this type of...
That's right, yeah, and quite often all the, there's quite a few scaffolded examples that will give you, if you go right click, use this model, they'll show you binding straight to the model, which is actually, could be called an anti-pattern.
Yeah.
But I don't like to throw the word anti-pattern around, just means, it's a pattern some people use, a pattern some people don't. Okay, so what I've got here, I finally decided to give up on AutoMapper. So I generally write my own mappers, and to be honest, it doesn't take that long. It kind of writes itself. So I just got used to it now. I'm going to add a new field, I'm going to add a mapper, and I'll knock these up pretty quickly. So generally I start by making some kind of interface for that mapper, and then I'll set up the corresponding configuration in Entity Framework. I only have to do it, in AutoFac. It's only once I go to AutoFac, all mapper types get implemented by the corresponding type. So I've created a few things in the mapper now. I've also got a list one here, so that'll work for my index page. So the mapper is fairly simple. It's basically copying values around. But what I like to do is actually take the bit of code that does the actual projection. So to turn an entity into a view model, the best way of doing it, if you can, and you can't always, is to use a projection. So projection is something you send into the Entity Framework queryable, and in the Entity Framework queryable, it'll actually map up those values. It does that by actually putting a select call inside the query. So in this case, the query that I run will no longer return me instances of my entity. It'll return me a view model instance from the query built from results of a select. So the start of the query will be select ID, select first name, select last name. So straight away, that's much faster than getting the entity, resolving the entity, keeping the entity in memory, and then mapping that entity through to a view model.
So is this what you mentioned before, like the iQueryable linking all the way or something?
Yes. So this is actually going to get fed into the select query, select clause of an iQueryable. What I've just done here is a little bit tricky. Is instead of putting it, so where you'd select, let me show you what you'd normally do. So in my select, I'd go select a student, so select new view model. I need to actually have the value S, and my typing needs to improve. That's right. Then inside here I can actually fill in my properties, so ID, s.id, and so forth. So that works just inside the select. But if you want to reuse that chunk of mapping, what you can do is you can take it out and turn it into expression func like that. And so that's the same expression you would have, but it's put in a separate object. So now when I'm querying a single item, I can actually get that object as an entity and actually invoke that same projection on the entity. Or when I'm dealing with a select over a list, I can just feed that projection in. So I'm just reusing that one piece of code. So one thing to talk about is the code that can go in here. The code that you can put inside this projection has to be stuff that Entity Framework knows how to turn into SQL query. So there's quite a few things that can't do that. If you're doing, say for example, you want to store all your dates as strings, and you want to send dates as strings through your system, you can't just go, date.format this, because there is no date format thing inside the Entity Framework SQL mapper. I believe it is possible to extend Entity Framework selects and have custom function there, but it's pretty involved.
Isn't it like easier to just dot to list and then?
Yes, the easiest thing to do is the .to list. So if you wanna, so basically what you can do is do select. If you just do .to list here, and then select, you can run any model binding you want. Problem with that is, I'm going to load all of my table and put it in memory. So if you are going to take that shortcut and call to lists, please, please, please do some paging first. Sometimes you have to do that just to get an object you can work with. If you're trying to do map and you just can't make it work with SQL, then by all means you can turn it to objects and then map from there. But just do a paging first, so you narrow the number of records you're going to do it with. Otherwise, you'll just eat your database, you'll eat your memory, and you'll have all kinds of problems.
Just a quick point as well. When you do paging as well,
Yep.
if you write straight up skip on page, that's
Yep.
how we do it.
Yep.
People try to do a to list on top of it, even before doing the skip on page.
Yeah, I think the order you do it is important as well. I think yeah. So you've got to be aware of what you're doing, because it's very easy to shoot yourself in the foot. Yeah, there you go. Yeah. So the other thing you can do is you can start thinking about. I'm not going to show you this. I haven't got time, but there's new things like OData kicking around where you can actually have as a standard way of sending queries into a web request and specify how the skip, take, and some filtering. And you can pass that through to Entity Framework and it'll pick that up. Haven't quite got time to do it there, but that's really your kind of mapping. You've got two options really. You try and map it inside what Entity Framework lets you do with a select, or you have to narrow down your results first and then convert from entities.
What was the problems that you had using AutoMapper?
I can't remember exactly. It was just things that would not map, or it's just things would be null, mostly coming back, like stuff coming back and not mapping properly, being null, but then being reset when you save it, and then data being lost, and that happening silently. Yeah. A lot of AutoMapper things happen without a warning, and that's the problem. It happens quietly and silently, and then you're broken. So in the end, as much as I hate writing mapping code and I hate kind of mapping things together, I've decided that just doing that work is far less of a headache than actually trying to debug a problem with AutoMapper. There's a good post on this on AutoMapper by Andrew Harcourt, and he puts it far better than I can. And his post is called "Friends Don't Let Friends Use AutoMapper." So if you want to know, I've kind of read through this and kind of agree with what he said. So take a look at that post. Okay, so we've taken that projection. Let me show you that screen.
It shows the edit case. How does the edit model work when it goes back to the view model as the model? How does that transformation happen?
Oh, yep. So that's the bit that's just done the ugly way. Let me show you that one. Nothing impressive here. It's just I set the values.
So that means, so hopefully it's very explicit.
Yeah, it's very explicit. Yeah. So I mean, I know that I'm not setting stuff that shouldn't be set, because I'm explicitly going, I know I'm getting these 5 fields back from my view model, and this is the most important bit really, because this is where you're saving. So it's worth spending the time to only map what should be mapped, what I know I've edited, what I know was in the screen, and what I know was formatted, and what I know was being validated by my validator. So what you'd also do is put the validation against these view models. So I quite like using Fluent validation, which that's a Fluent API for attaching validation to a view model object. I'd put inside my example here, I've actually got this model state is valid. I'd have a Fluent validation wired up to check that view model coming in, validate it, and then just save it. What's my
In that bit of work,
Yep.
so where do you keep the DB context?
Okay, yep. So the pattern we've got here is, so we've got two things. We've we've got the repositories and the unit of work. And the unit of work basically contains all the repositories that I've fetched. And it's a pattern I'm not 100% happy with here, because what we do is we've got these repository objects, and we've got a unit of work. They're connected, but you don't see the connection explicitly. They're connected behind the scenes by your dependency injection object. And I've not found a good pattern to get work around that. Obviously, what I could do is have a unit of work pattern and then had access to all the repositories through then, but then I've lost some of my ability to inject different implementations because everything's hooked up. I could put a dependency resolver inside my unit of work and then it's explicitly linked together. So yeah, what I don't like is how my unit of work and repositories are linked behind the scenes, not explicitly in front of you, but I haven't found a better way to cope with that.
Do you keep these DB context in the HTTP context?
Yes, the unit of work basically just wraps multiple DB contexts. So all they do is you call safe changes, it loops through the list of contexts it's got and calls safe changes on those. So it's not a big or clever class, it's just...
That whole purpose of the main advantage of unit of work, is it because when you go for distributed transactions, it supports more, is it?
Yeah, I mean, definitely. I mean, certainly it's a more onion architecture style way of describing it, I guess, because if you're not using entity framework, then you're not using DB context, but unit of work would apply if I've got a collection of in-Hibernate sessions instead, or any other transaction going on. So it's really just taking this functionality and wrapping it in the words that are used in onion architecture.
Can you show us the implementation of the unit of work?
Probably not easily because it's in a library. I'll have to decompile it. But it's not clever. Let me see if I can get to it. I'll see if I can Control F12. Maybe I'll No, but what I will do is run forward. So what we've got here, and one thing I like about this pattern is I'm now no longer injecting my repository directly into my controller. I'm instead injecting the mapper. When you think about what a controller does, the job of a controller is take stuff from the web and give it to the next layer. So now I'm no longer, my controller doesn't have to care about the repositories or my entities, it's doing its actual job, which is taking stuff from the web, passing it through to my mapper layer, and then vice versa. So that's a kind of a cleanness I like about this approach. That's my next one. Okay, next thing to show you. Oh, it's already there. So you've got a system, you've built it up, and it's using Entity Framework, it's using Data Onion, and you've got it all set up. And how do you sort of make sure that you're not doing the wrong thing? How do you know that you're doing the expected amount of queries? A very quick and easy way of doing that is using Glimpse. So Glimpse is a little tool. You install the NuGet package. It installs this stuff about your request. How long the request took, how long the action took. And so here we can see straight away, now that we've switched to the view models, even though we've got this aggregate lookup going on here, I can see that there was only one database query ran, and it took 0 milliseconds to run. So that's a useful way of debugging and making sure that I am actually doing the right thing and not having too many lazy loading queries firing off in the background. Glimpse. Yep, so that just runs in every single request and just puts itself there. You can turn it on and off. Gives you various information about your current request. So a good debugging tool. And that's kind of the easiest way of having a quick look. Obviously, you can log all the things that the DB context does. You've got all kinds of logging available, but that's a really quick, easy way to just check a single page as you go. Okay, I've got a couple more things to show you now before I wrap up. One is a kind of it's an entity framework feature, but I'm going to show it to you because it's quite involved to set up, and it's also just to prove that now we've got this repository in the way of entity framework, we're still able to do stuff with entity framework. All the stuff still works. And that is concurrency tracking. Okay, so by default with Entity Framework, if you load something and save something, it comes from the database, you save it overwrites. If someone else at the same time loads something and saves something, whoever saved last just wins and it goes over the top. You can manage some of that by using optimistic concurrency control fields in your database. And this is more a database feature rather than anything else, more an Entity Framework feature, but you can punch it all the way through. So what I've got here is a new field called row version, and it's a byte array, and it's been marked as with a attribute as timestamp. Now obviously that's not what I'd normally do. I'd probably take that and put it in a fluent validation setting. There's a corresponding fluent validation setting for that. So that marks that as a timestamp. That gets converted into the database as a row version field. Let me run that. On the test. So when you look at that in the database, you'll see that it's put in a row wrong database. So it's got this new field row version. So the way this works is, with a row version in place, every update query that Entity Framework sends back, it sends back update these fields where row version equals the row version that they got when it loaded the object. So and if that query returns 0 because it didn't find that record, it then knows that there was someone else has come in and they've changed the record, and it'll fire back an optimistic concurrency exception. So that works in Entity Framework when you've got two contexts open and they kind of run at the same time. But what we've got here is a web application. We're taking our object and sending it all the way out to the web. It's sitting on a browser for a couple of minutes and then sending it back. If we just relied on Entity Framework, when it came back from the browser, Entity Framework would load it again with the new key, just stream the values in and save it without knowing that it's changed. So what we need to do to make this concurrency check work in the web context is send this row version all the way out to the screen and back again when it comes back in with a post. So very briefly, the way I found to make this work. My viewbundle now has a row version. But a byte array doesn't work very well for sending out to the screen, so you've got to convert it to a base 64. So I've created a little getter setter to turn it into a base 64 string, and then in the view, I've got a hidden field that catches that base 64 string. Then on the save changes, we need to do a little bit of extra step. So save changes is a function right in the database context. Okay, so this is the method that's called whenever there's some changes to be saved. And it's actually got a change tracker.entries. It's a list of all the entities that have been registered against that context. So what we need to do is we need to look in there, because obviously we've just loaded something and its original version is the one it's just loaded, not the original version that was saved against my view model. So we need to detect there's been a change in the row version and then write the posted row version into original values in that record. Then when it tries to save that record, it'll pick up that there's been a conflict, a change conflict. The best way to demonstrate what happens now is to run it in two browsers. Installing updates. Run. There we go. Okay. Copy. So edit on one. Hit edit on the first one. Hit save on one. And then hit save on the second one. Let's continue that so you can see the error coming through. So straight away you can see the error message is quite descriptive. Yeah, that's great. How about you move yourself, clutter? You are clutter. Get out of it. That is what I want to read. How can I make you go away? Die. No. I'm going to have to highlight it down here. Yeah, so what it says is entities may have been modified or deleted since entities were loaded. So that's the exception that it's raised. So it's detected the concurrency change. Now, one of the important things is the bit of code that exception fires from is inside the DB context. It has copies of both the original and saved changes. So you can actually intercept that thing and then actually show to the user the two sets of values and what was changed. So that's quite useful. That's really just a feature that I wanted to show you just because it's a nice feature to do. You should think about doing it, but also to prove that us putting the repositories in the way hasn't stopped that from working. That advanced entity framework feature is still there. So is there a question?
You check that if it didn't match the existing value, but then you set it anyway. Is there a reason why you reject it outright?
Say that again?
In the code where you did that check.
Yeah, I might have got something wrong in that code, so let's have a look. I looked at quite quickly. It's worth looking at again.
So if there's a growth version that doesn't match, why don't you just reject it?
Oh yes, the current values.row version. Let me think of this through. Okay, so I've just loaded something from the database. It will have an original values.row version and a current value.row version. Yes, the original values.row version will be the updated version by the other guy, and the current values.row version will be my original version that I had from my request. So that's why they will be different. Because the current original, I've just loaded this record and the other guy changed it. So original values is the other guy's key, current values is my key. If they conflict, then I need to do something about it. Yep, so then what I have to do, I have to trick Entity Framework into thinking that I'm saving something and the record was loaded by me previously. So I put my version of the key into original values.row version. Then when Entity Framework tries to save it, it knows that it's blocked.
The question is, why would you just throw an exception in
I could just throw an exception there, yes, rather than passing to Entity Framework. That is right.
So
Yeah.
it should have passed without an error when you ran it. Right?
Sorry?
Because you ran it and it gave you an error saying that the entity has been modified already.
Yes, yes.
So in that case, you should have said, okay, I'm going to save it.
Yeah, so I could have picked that case up. That picks up the problem case anyway. And so I think what I'm trying to do is recreate the exact state of the thing that happened rather than maybe some other things going on. So I wanted to recreate what it, basically if I wanted to recreate the state in the object to be as close to as possible what it would be if I'd opened the context, kept it open that whole time, and then try to save it at the end. So I was trying to recreate that state rather than trying to actually intercept that problem myself, because it may be something else that's different about it. So I wanted to just try and send it to Entity Framework in the same state it would have been if I'd kept that context open and not closed it between sending it to the screen and back. One thing you can also do is keep context open for a ridiculously long time, but that's not something I'd recommend. Yep.
Yeah. If we do this kind of thing,
Yep.
no point of getting the raw version, because here we treat the entity framework, right?
Yeah.
Rather than-
But yeah, you're right. We know there's something wrong there anyway.
Yeah,
But
because-
yeah.
So it means we ignore that concurrency issue.
Yeah.
Right. So rather than using the raw version, we can get the object from the directly from the database.
Yep.
And just we can assign values as we did before, and we can
Yep.
save it, right?
Yeah.
Yes,
But
like the last person win then.
Yeah, but that's last person win, because the problem is I've got an object coming back from the web, yes?
Yeah.
Yep, it's coming from the web, but I'm going to save it against an object I've just loaded. And that object already has the other guy's change. So how do I know that my conflicts with the other guy's change? Because I could maybe look at my original row version and but if I just save it, it won't detect its change because I've just loaded it.
Yeah.
Because it's been out to the web.
So here also you do the same thing, right? What you are doing is you assign that latest record row version into this.
Yeah, so what I'm doing is I'm trying to recreate the state it would be in if I'd kept that context open. And then raising the same exception that would have been, so, and being able to get basically trigger what Entity Framework would do if I'd had that context open the whole time. So I'm basically mimicking what would happen if I had a context open the whole time for that operation. What's actually happened is the context is closed, it's loaded again, I need to recreate the state that would have been if it had stayed open. And that's the exception it would have thrown if the context had been open for that lifetime.
So what do you think about now here, we are doing a lot of things in the control class, right? But in actual implementation, we do those type of things in the business layer, right?
Well, this is really an Entity Framework feature, unless you want to put. You could put your own context tracking in the business layer if you wanted to. You don't have to use this. So that's up to you. Yeah, you could implement it there if you wanted to. And certainly it's a business problem if you get a conflict like this. And so what to do next is definitely a business problem. So it's a good argument that it does belong there. But I was just showing you this feature. There's more than one way of doing this. But this is really showing you Entity Framework support for that row version. Entity Framework itself has understanding of the row version column and will work with the row version column without you having to do anything apart from add that timestamp field. But if you want to have that timestamp field work with the web, you're going to have to do a little bit more work to keep track of it. But by all means, that's not the only way of doing change tracking. And yes?
Do you see any value in breaking up the context based on a logical separation of entities?
Potentially.
In cases where people have done it, like for every 3-4 related entities, you have created a separate.
Yeah, I mean, that's starting to break up. You're almost talking more microservices there, aren't you? You've got little bits of separate databases. I mean, it does give you good separation concerns, and it also stops you going down too many hops, because you could potentially put them in separate databases. Yeah.
The problem we've got is that every developer that needs to work on a different base will need to run an ask us, where should I put this?
Yes, there is that, and there's also, I guess, if it's broken up, you're not going to get any of those conflicts, because I'm working on that chunk of the system. I can make my migrations without worrying about what the other guy's doing, because he's got a separate set of migrations. So that's an advantage. But it really is how every time you break something up, it makes some things, it makes it more separated, which is good. Then it makes some things, the communication between those chunks, harder. So there's swings and roundabouts. So the first few people to hand in one of those completed will get a free month of Pluralsight as well. So. Okay, I've got one more thing to show you and then I'm done. And that is a little bit about performance. Yeah, you hand those out as you get the things. Okay, so the last thing I want to show you quite briefly is just sometimes how slow Entity Framework can be, which would be in consideration if you've got some bulk processing, because it can be very, very slow. So what I've got is a very simple example here, and unfortunately I did have a Seek server running, which would show runtime logs, but I might have to fall back to log into the file instead. So I've got a CSV file with 4,000 students in, and all I'm doing is I'm just going to loop through, add them to my repository and call save changes. So nothing too clever there, but that's kind of how, that's just doing vanilla Entity Framework, nothing going on. So let's take a look at that. Now the problem with Entity Framework is as you add more and more stuff into your DB context, that DB context starts to slow down. And in fact, it's not even a proportional slowdown. It gets exponentially slower and slower to the point where one record at a time starts ticking through. So you have to be careful. If you want it to perform well, you've got to keep your context fairly small. So in this example, I've been trying to import 4,000 records, not a lot for a database to import. You can see it's still running. I expect this to take around a minute, which is not impressive. And it's still going and still going. So again, the code, I will show you the code for that in a second. Okay, finally finished, and that took, so that took 68 seconds to do 4,000 records, just because as it filled up, all that stuff was in memory, and it's not just the memory of the item itself, it's all the context memory it stores about that stuff. Just those two collections I gave you. Okay, so we look at, so by itself, just streaming stuff into the DB context and then it's save. Far too slow, 68 seconds for 4,000 records. So the first thing you can do to make that faster is to actually do less in a single context and actually use multiple DB contexts. If you clear your DB context out, like delete it and get all the entities out of it, it stops slowing down so much. So sometimes this is what you have to do, but obviously there are better solutions. So in this better example, what I'm doing is I'm actually, every 50 records, I'm wiping out the DB context. Now I've specifically set up the unit of work here for Data Onion, so that if you dispose the unit of work, it'll wipe out the context, and next time you have a repository that asks for asks for its DB context, it will actually automatically go, oh, you need a new one, and new it up for you. So that's why internally, our repositories are wired up against a DB context manager, which has reference to a DB context factory, so it knows how to create more stuff when it needs it. So with that in place, you can see a significant improvement. Is that running? Yes. So just that one change, where instead of running in batches of 50, wiring everything up front, it went from 68 down to 10 seconds. So that little change made quite a bit of a difference. Obviously that's still not particularly fast. So at the end of the day, one of the key things about using a repository pattern is that you've got a place to put your code. So underneath my interfaces, I've created a new partial class and given it a new function to run, and then in my data layer, a new repository pattern and an implementation for that class. So what I'm doing here, I'm actually getting the database connection itself from the connection string, creating a new connection, setting up a prepared statement, and looping through the prepared statement. So now I'm bypassing entity framework completely, but because I'm using a repository interface and a repository pattern, I've got somewhere to put that code. So if I run that, and obviously this is not very scientific, I'm not running multiple tests, but you're getting an idea. There's all order of magnitude changes between these approaches. So, so selecting into anonymous object is you can do that. Yeah, that does a projections, that does a select. So that will bypass loading entities and everything. So that is faster. Yes. Yeah. Well, this is for an update, not a select though. I'm doing an insert statement. I'm taking 4,000 records from a CSV file and inserting them in. So yes, a select into anonymous object is fast, but for an update, looping through and calling update is very, very slow. So with a custom function that went straight to SQL, down from 10 to 2 seconds. So again, another massive saving. But I've got one more technique to show you. Yes, there is. Yes, there is. Yep, so that's this one, yeah. So finally, version 2.5. And this is what we wired this in straight into our repository pattern. So by default, the repository you get with Data Onion has a bulk insert function. So here's my final test, and then we can all go home. So my repository has a bulk insert function that just takes that list of students. So if I run this one, and what this does is it automatically maps your model and turns it into a bulk insert statement, and this one runs. Got to build it first. Okay, that one took it down to 0.7 seconds. So there's quite a few options there to speed it up. Just remember that if you're doing a lot of things, if you're starting to loop through stuff, entity framework is slow, try and find a way around. Obviously, bulk inserts only work when you're processing new items. So at some point, you're going to have to write some SQL and just do something the SQL way. Yes? Yes, you can. Yes, that's another thing you can do. Yes, yes. And that's something I haven't quite got working right with this repository layer. So that's something I'm going to look at next to get the ability to turn it on and off, because it's not one of those settings that's kind of per context. You take the whole context and turn it on and off. But certainly one thing I'm going to look into is things like maybe for all select statements, most of your web requests are either GET requests or push requests, aren't they? Like you're doing a HTTP GET, you don't need change tracking on for that. You just want to get your data out. And in fact, if you're using projections anyway, you're just going to get everything you want for that request in one quick select GET, and then through you go. But yeah, there's plenty of other things you can do. Yes. Say that again?
Those entity framework related to support bulk insert?
No, that's there's an extension on Entity Framework that supports bulk insert, and we've added support for it to our Data Onion layer. That's, don't think so. It just drops them all in, and you have to query again to get the IDs back. Don't quote me on that. I'm not 100% sure, but I certainly don't get them back. I just send it in and forget about it. So finally, I'm going to just have a couple of quick things. Obviously, this is quite useful for a lot of people, but I wouldn't say it's going to change your life. For a start, every single ORM that's ever been made is painful. Think about what you're doing. You're taking all these entities and you're running this massive process on them and then turning it into a magic an SQL string. Then you're running the SQL string against the database and then bringing it back and then turning it into entities again. It's kind of clunky and it kind of works, but it's surely not the final answer. We're going to have to find something better soon. A lot of people have been looking for the better answers, all the NoSQL crowd, and they haven't quite got there yet, I think. There's certainly some certain workloads are better with NoSQL tools, but certainly say the document data stores, as soon as someone starts talking reporting, you're in big trouble because you've got all this stuff stuck in documents. Well, that's it. What you can do is, reporting very rarely needs to be live. So you can have your document store and then have a nightly process that just denormalizes that into some tables built for reporting and be reports from that. There's plenty of things you can do. But, ORMs are not the answer to everything. And again, there's quite a few people, just when I was sort of getting well into the repository pattern, I saw a whole bunch of posts saying that the repository pattern is an anti-pattern. Most of these people are people that like working with Entity Framework and the tools it gives. And all the examples of the repository pattern they gave you are ones that didn't let you use our queryable. So what we've done is we've added enough stuff to our repository pattern to make it usable. But by the same token, you're still, you're finding that middle ground through the middle. Entity Framework's rubbish at set operations. You've got a whole screen full of stuff, and you've ticked 10 of them, and you hit save. To process that with Entity Framework, you've then got to go and load each one in turn. Or you just got to have to bypass Entity Framework, because databases are great at update this, where this. It could be 1,000 records. So set operations databases are faster at. So at some point, we're looking at everything I've shown you in the domain so far. It's just been pretty basic property bags, really. I haven't shown you anything clever with the domain. I've not shown you DDD stuff. I've not shown you anything really going on. It's just this bag of properties. So at some point, if you're going to be doing more with your domain, you're going to hit the point where what you're trying to do with your domain doesn't map very nicely to Entity Framework. So you're going to have to either compromise your domain or decide to go an extra path and actually split out your domain that you work on versus the domain that you save. You have to map between the two. And there's no golden rule on how to do that. But certainly if you're starting to do DDD, which takes this stuff much further, so with DDD, you start manipulating your objects much more in this domain style, and you start, instead of presenting a property bag, for example, in DDD style, you'd actually have specific functions, so it's impossible to set the wrong thing. You wouldn't have a customer with an address and then all the fields of the address being settable. You would have a single function with customer.setAddress, and it would take an address object and only allow you to manipulate the address through that interface, not let you go, address 1 without setting address 2. So that's one of the core concepts of DDD, which is not this is a step towards there, but this isn't getting you there. So that's something you have to look into. When you're talking about units of works and repositories, the database Entity Framework DB context is kind of a repository and unit of work anyway. So you've taken this Entity Framework unit of work and this Entity Framework repository style pattern. They claim to have kind of been, they claim when they say about Entity Framework, they're certainly inspired by those patterns. So you're taking this abstraction and we're putting another abstraction in front. I still think that abstraction is useful, but you've now got two abstractions in place. But I think having that repository place to put your code, to put your customizations is valid enough to have that extra hop. Again, there's plenty of things in real relationships that you want to map up with a model that aren't really mapped very well in entity framework. Things like you've got a reference between two objects. One's and they're done by having an actual reference there. It's a property on your data on your model. You can't tell just by looking at that property whether it's a refers to type relationship. So I've student. I've got a reference to a school. Then that's a reference to that school. If I delete that student, that school doesn't belong with that student, gets deleted with that student. But if I've got a student and it's got my my marks, my test scores, that belongs to me. If I delete that test score, delete that student, I want those test scores gone as well. And there's no real good way in the models to really highlight those differences. So finally, I'm just going to mention a few things that are not covered in the talk. They're probably talks in themselves, but are worth looking into. One is, of course, the thing that everyone talks about when they talk about Onion architecture, and that is domain-driven design. I've not had time to cover that as well. Domain-driven design takes the concepts I've introduced here with the domain-first pattern and runs much further with it. There's a lot more with it, so you definitely should take a look. Some other things that are often talked about with Onion architecture are event sourcing and CQRS, which is command query response something. Segregation, that's right. And the final thing, which is quite cool, and I think we should see a lot more of in the future, is JSON support inside databases. So Postgres, which is a database, has a new, obviously you can just take JSON and turn it into a string and put that string in the database. That's maybe a hybrid way of having some relational stuff and then some stuff that's like a document object model kind of type of pattern. I know a few people that are starting to do that now, just so that they can try and get the best of both worlds. The JSON support in PostgreSQL goes one further because it doesn't just take a string of JSON, it actually indexes that and turns it into a kind of B-tree array thing inside its memory, which means you can fast query on fields inside that JSON. So you can query where and then 3 hops into the JSON, get stuff out. It's pretty early and it's in prototype stage, but Postgres has it. One guy has taken the Postgres support, the JSON support in Postgres, and turned it into some plugins for SQL Server. I don't think it's going to take off. I'd love to see it in SQL Server, but that's something to think about. That could be a good way to get forward. Or just some new system that's like a database, has all the kind of maths that databases have behind them, but lets you just write SQL, use link against them without having to convert it to SQL first. Like at some point, all these database manufacturers are making databases, and then they write an SQL layer for whatever internal model they've got for that database. But if someone could take all that database engine stuff and just write a link layer instead, we'd get rid of this horrible mapping problem. So those are things to think about. To finish up, I've been Brendan. I work in Brisbane. For SSW. I think SSW paid for your pizzas. Yep, so thanks to us, yay. And we're for hire, so by all means, we'd love to hear some feedback, and thank you for your time.
Did you get all that? We'll take the SSW TV quiz and test your knowledge now.